So here we have the 2016, this is junior cert, higher level, and so it says, is the point 3 minus 5 on the line 5x plus 3y plus 6 is equal to 0? So if a point is on the line, that means it's going to satisfy the equation. Well, what does that mean? That means if I plug in that point, if I plug in the value for x from that point, so a point is going to be in the form x, y. So if I plug in the x value in for x, if I plug in the y value in for y, that I should get 0 is equal to 0. But if I got something like 5 equals 0, well then it wouldn't work, so it wouldn't satisfy the equation. So I'm going to plug this in and see does it work out. So my point is 3 minus 5, so I'm going to sub in x is equal to 3 because x is my first one, and then y is equal to minus 5 because the y comes second. So 5x plus 3y plus 6 equals 0. So I'm going to sub in 5 by 3, and then 3 by minus 5 plus 3 by minus 5, and then plus 6, and then equals 0. So we're going to see if this actually works out. So 5 by 3 gives me 15, and then 3 by minus 5 gives me minus 15, and then plus 6 is equal to 0. So 15 take 15 is 0, so that leaves me with 6 is equal to 0. Well, 6 is not equal to 0, so the point is not on the line, so it doesn't work out. If I got 0 was equal to 0, I could say that it was on the line, but the point is not on the line, so it doesn't work out because it doesn't satisfy the equation. That would be, say, my justification of that. And then the next part is find the point of intersection of the following lines. So I have 3x plus 2y is equal to 7, and then y is equal to minus 2x plus 5. So I have two ways of doing this. I can do simultaneous equations first, or I can write them both in terms of the same variable and then let them equal. So what I might do first is simultaneous equations. So that's the first method, and that's probably the most common method. So in order to have that, I need to have x and y on one side and everything else and the numbers on the other side. So 3x plus 2y is equal to 7. That's fine. And then, but this one, I'm going to have to bring over my 2x. So it'll be y plus 2x is equal to 5. So then I have to then say, if I want a variable, so I'm also going to maybe put my x's underneath my x's and my y's underneath my y's. So 3x plus 2y is equal to 7. So then I'll have 2x plus y is equal to 5. So it's just handier to have them all underneath. So we have to get one of these to cancel, one of these variables. In order for them to cancel, they're going to have the opposite sign, and they're going to have the same coefficient. That means the same number attached to them. So in order, I think the easiest one would be to get 2 in front of both of the y's. In order to do that, we're going to have to multiply both sides of this line by 2. If we do the exact same thing to both sides of the equation, it stays the same. So I'm going to multiply all of this by 2, so it'll be 4x plus 2y is equal to 10, and then I'm just going to bring down my other one, so 3x plus 2y is equal to 7. So now what I have to do is, they won't cancel as they are. 2y plus 2y will give me 4y, so I have to have a minus in front of one of them. In order to do that, I'm going to have to multiply both sides of either one by minus 1, so I think I'll pick this one. So multiply by minus 1, so that'll be minus 3. So I'll just write down minus 3x minus 2y is equal to minus 7, and then 4x plus 2y is equal to 10. So then I have 2y plus 2y minus 2y, so that'll cancel. 4x takes 3x is going to be x, and then 10 takes 7 is going to be 3. So I get x is equal to 3, and what I can do as well is then I can plug in my value for x. So I get that into either one, so 3x plus 2y is equal to 7, so I can plug in x equals 3 plus 2y is equal to 7, so 9 plus 2y is equal to 7, so 2y is going to be 7, take 9, 2y is equal to minus 2, so y is equal to minus 1. So the point of intersection is going to be the x value, then the y value, so it's going to be 3 minus 1. And I'm just going to show you another way that we could possibly do this question. So that answer that I just did there was correct. You can do it that way, that's no problem, but I just want to show another way. So what we can do is write each of these equations in terms of the same variable, like write them both in terms of x or both in terms of y. I think because this is already in terms of y, I might write this one in terms of y as well. So that's 3x plus 2y is equal to 7. Firstly, to get it in terms of y, I'm going to have to get y's on one side, everything else on the other. So that'll be 2x is equal to minus 3x plus 7. I need to just have y by itself though, so I'm going to need y is equal to minus 3 over 2x plus 7 over 2. And now that they're both in terms of y, so this is equation 1, and this is equation 2, I can let them equal. So let y equal y, and I should get the exact same answer as the other way. So 2x plus 5 minus 2x plus 5 is equal to minus 3 over 2x plus 7 over 2. What I might do first now is multiply both sides by 2 to get rid of my fraction. So multiply by 2 and then by 2. So that'll be minus 4x. And then plus 10 is equal to minus 3x plus 7. So I might get x's on one side, numbers on the other. So minus 4x plus 3x, and then 7 minus 10. So that's going to be minus x is equal to minus 3. So if I divide both sides by minus 1, I'll get x is equal to 3. So I got the same answer as before. Now I just have to go back and sub in x to get my y. So 3x plus 2y is equal to 7. So 3 by 3 plus 2y is 7. So 9 plus 2y is 7. So 2y is 7 minus 9. So 2y is equal to minus 2. So y is equal to minus 1. So my point here is 3 minus 1. So I get the exact same answer either way, whatever way I do it. So that is our answer. Thank you.